In example 3, we've got two people. So we've got Dima and JD. They're on a raft. And so if you can picture, this is like a top view of the raft. We've got like a wooden raft, and we've got, let's say, I don't know, one of them's Dima, one of them's JD. There's the two people. We're seeing their heads. And initially, they're standing still on the raft, but the raft itself is moving at 4.5 meters per second. So let's go ahead and decide who is who in this. Let's say the raft is the first object here, 39 kilograms. Dima, 65 kilograms, and JD, 43 kilograms. Okay, so that means raft is 1, Dima is 2, JD is going to be 3. Initially, the raft is moving at 4.5 meters per second. If Dima is standing still on the raft, she's also going at 4.5 meters per second. JD, same thing. They are all going in the south direction, 4.5, where is it here? 4.5 meters per second. So we've got 4.5 meters per second south for all three of them. That means because they're all moving straight south, that means this is 0, 0, 0. They all have no x component as we work through this. Then kind of afterwards, it's not really a collision in this case, but you can think of it like a collision. I think the textbook mentions, they call it like an interaction. Dima starts to walk with a net velocity 1.1 meters per second, east 15 south. So I don't know, maybe she's here, that's east 15 south. Let's draw it here. Let's say this is Dima. She's going east and south, 15 degrees. If this is, Dima is number 2, so V2 primed, she's going to go this way at, Dima starts walking 1.1. This in here would be V2x primed, and this here would be V2y primed. So if we look at that, to find these x and y components, we can break that up and find them. I'll go ahead here and say this is 1.1, what would that be, cosine, 15 degrees. I'm just going to leave it like this. If you want to figure that out as a number, you could figure it out as a number. I'm just going to leave it like this time. This would be sine 15 degrees. JD, on the other hand, let's squeeze him right in here. JD, he's kind of going southwest, southeast, I guess it was. Where is it? South 12 degrees east, yeah, here. So he's going to be V3 primed, and he is going at 0.85 meters per second. V3x primed and V3y primed. So there's the components for JD. That would make this 0.85 sine 12 degrees and 0.85 cosine 12 degrees. So yeah, we're just breaking everything up into components. And again, this is similar to our last question. What we're looking for, this is just a three object one. The last one we did was 2 objects, but we're doing it the same type of thing. We're doing it with conservation of momentum. We're going to have to look in the x direction, y direction separately. Really what we're doing is just kind of break everything down. Mass obviously is a scalar, it has no components, but any velocities that you're given, just break them up into their components. Okay, so now we're going to look in the x direction. That's an x. And we're going to write out the big long conservation of momentum. So let's squeeze it down here. M1 V1x plus M2 V2x, M3 V3x. And then all the primes on this side. And then we're just going to go and fill stuff in. We know V1x is 0. This one right here is 0, V2x is 0, V3x is 0. All of those things cancel out. Again, this doesn't always happen, but it's not uncommon for one of the axes to cancel out. This won't be true in the y direction. Then we're going to keep just putting numbers in here. I chose south and east as positive, so we're looking in the x direction. This is the east direction. V1x primed, we don't know what that is. Mass 2, and this one, I'm just going to leave it like that, 1.1 cos 15, mass 3, 0.85 sine 12. Decimal there and there. As we work through these, just keep in mind if, in my case, both of these are east, so let's just maybe stick that in here just as a reminder. This is east, this is east. Okay, whatever those things are, they're going in as positives. If one of them was west, I would have to put a negative sign in here just to indicate that it's in the opposite direction. Okay, so that didn't happen here, but it could happen. And let's see, I got some numbers here. 39 V1 X primed. This one 65, so this is 69. And the last one 7.59917. We can rearrange and solve for this thing. V1X primed it's a negative 1.9657. Just remember that is in our positive direction. Whatever we chose as our positive direction. Negative east means positive west. Okay, so I'm going to leave it like that for now. Save myself a little bit of room. But this vector here is west. We're going to do the same thing over here in the y direction. Write out our big long equation. Should have like some nice instrumental music or something playing. You can put on your own music as I boringly write all this out. All right. Where is this one? This one, we've got all these numbers. Yeah, so M1, 39. V1Y is this thing. Again, I said south is positive. M2. V2Y, 4.5. I guess they're all 4.5 on this one. If that's true, which it is in this case, we could factor out a 4.5. We could kind of consider this like one big object. Add all three masses and multiply by 4.5. That works as well. I'll show it this way just because more typically it's like that. Mass 1, still 39. V1, we're on Y. V1Y primed, yeah, we don't know it. Mass 2. V2Y primed. Again, check the direction. In this case, it is south. South is positive, so it just goes in like that. Positives. This is 43. This is 0.85. Cosine for Y. Cosine of 12. Ooh, just barely squeak that on there. Now we can go ahead and work all these things out. All of this stuff here, the whole left-hand side ends up being, what is that? 661.5. I'm going to move over a little just so I've got enough room here. This one, 39 V1Y primed. This 65 times 1.1 sine 15, that's 18. And this is 35. Okay, we're going to do a little bit of math here, and I'm going to skip ahead just a little bit. V1Y primed is 15.5703 meters per second, and that is south. And again, not our final answer. Once we've got those two, we're just going to put them together. We're going to redraw the triangle. Remember, this one is actually going west, so we are going, let's put it over here, we're going south and we're going west. So this is V1 primed. V1X primed, or V1 primed X, is here, 1.9657 meters per second. V1Y primed. We're going to solve for that side and that angle. So we use a little Pythagoras. V1 primed is square root of if we work that out, where do I have that? It's about 15.7 meters per second. We got to figure out that angle as well. And as always, we'll pull out our trusty tan. And this ends up being, I think it's about 7 degrees. So then our answer, V1 primed, what did it ask? Determine the resulting velocity of the raft. Yeah, so V1 prime, the resultant velocity of the raft. I guess we would have 2 sig digs. I guess we'd say it's approximately 16 meters per second. That is south, 7 degrees west. And we can stick our vector sign on there. There's our final answer. Did I get that in? Just barely. South 7 degrees west, or west 83 south. I can't remember which answer I gave you on the video.